Right, well, welcome to Environmental Science. This is Bio 202, and I'm making a short little video here just to give you guys an idea of what environmental science is and what this course is all about. The idea is that typically bio majors take the course, folks who are looking to move towards an environmental, ecology, nature, conservation related degree. If you're interested in restoration work, this is definitely an important type of course. It does help round out your educational portfolio for folks in biology who are moving in possibly different directions as well. If you're heading towards med school, they often like diversity in your coursework. So the idea with environmental science is to give everybody a foundation on what it is. But the way I'm going to teach this course is a little different than what you may have done in other courses. So the course is structured so that you should have some background knowledge about biology, ecology, a little bit of chemistry, some basic information. High school biology, 100 level biology courses will provide you with the foundation necessary for this course. When it comes to the course itself, about 50 to 60% of the course is based on what's called Bloom's Level 1, or remembering concepts, remembering definitions, terminology, things of that nature. Again, a lot of this is going to overlap with any previous biology course that you may have taken. Roughly 30 to 35% of the course is, can you understand what this information means? So you memorized stuff in your previous courses. Can you then understand what it means and how it works and some of the basics behind that information? And then a smaller component of the course, about 10 to 20%, is can you apply it? So do you know who came up with the Clean Water Act? What is a Clean Water Act? Why is a Clean Water Act important? How is it working today? That's kind of the progression of knowledge that we're going to work with throughout this course. So it's not a just suck it in, regurgitate it back out type of course. There's going to be this understanding and application of content. And it becomes real world examples. We're going to work on a restoration project. We're going to work on water quality monitoring. A lot of the things we do, especially in the lab side of things, is at the application or the apply level. So we need to remember basic facts, understand those facts, and then put those pieces together when we get into the hands-on stuff in a lot of our labs and some of the different projects we'll work on during the course. Now, an important thing to do is for everybody to know what kind of learner they are. Are you a visual learner, an auditory or oral learner? Can you learn by hearing? Are you a read writer? Are you a kinesthetic? Or are you a combination of all the above? So knowing this makes it very, very helpful for your success in any course, not just environmental science, but any of your classes. What I will do with the course is all of these learning styles will be part of the course. So there are things where, wow, let's go and take a look at it. Flow charts, diagrams. We're going to be listening to content and information. We're going to have to read information, and then the application and the hands-on doing part of things. So I try to make sure I hit all learning styles, but you guys definitely will want to know what is your strength and best learning style. So I do a lot of things differently in this course than most of the other courses I teach. There's a lot of learning activities, hands-on stuff. So we talk about basic concepts in lecture. Some of the lecture will be online, some of it will be in class, and then we do stuff. We do a lot of different learning activities. So this is not a just sit and listen to me type of course. I want you guys actively involved in the learning process. You're going to be actively involved in the teaching process. You'll be working on different projects and then explaining that to the other folks in the group that are working on a different project, and then we take all these different components and we bring it together. So again, don't think this is I can just sit in the back of the room and hide for 16 weeks type of course. No, everybody's going to be involved in the learning process. You learn more by doing, by being involved, than by just sitting and listening and trying to avoid being active in the learning process. So we're going to talk about environmental science. What is it? What are the environmental laws and policies out there? What's some of the history of those laws, like the Clean Air Act, Clean Water Act? What is the EPA? A lot of this is in the news right now. There's a lot of major things going on in the news in regards to environmental science. So we want to look at the history of these acts, these laws, these policies, these programs. What is their current status? And then we'll discuss and debate the pros and the cons. Should we repeal parts of the Clean Water Act? Should we repeal the Clean Air Act? Should we loosen those regulations or should we tighten them back up? That's something you guys need to be able to make a judgment call on, but base your decision on knowledge and facts and information. So we start the semester off with just that background and that history. That's our first unit. We then move into ecosystems. So this will look real familiar if anybody's taken general bio or a previous bio course. What are the features and components of ecosystems? So let's look at ecological interactions. We can focus on different ecosystems. We will be doing a lot of work in the pond at the campus. We'll be testing the water quality. We'll do population studies in that pond. I'll bring the kayaks. You guys will go kayaking. And the idea is to learn more about that particular ecosystem, the aquatic ecosystem in our backyard. We'll also touch base on other ecosystems as well. Second unit there. Third unit goes into population ecology. And again, it should look familiar. What are the factors that influence population growth and decline? What are the consequences of human population growth? So we want to look at this ecology and figure out what's going on with populations and then apply that to things like, all right, what if we want to grow a bigger population of pheasants or chickens or corn or beans? What if we want to decrease a population of a parasite or some organism that is causing problems in human health? We need to understand how populations work. So we'll spend a unit focusing on population ecology and how environmental factors play a big role in this population ecology. We then talk about some of the abiotic components of ecosystems or to the different ecosystems. So the non-living, what's going on with the water quality? Atrazine, is that in our water in Springfield? Lead is in our water. What about some of these other pesticides and herbicides and contaminants in water? Well, that's what the Clean Water Act is supposed to prevent. So we'll talk about that. So we'll kind of connect this back to the first part of the course. What's going on with the quality of the soil? What type of soil do we have? Why is the Midwest so fantastic with farming? It's because of the soil quality. So what is soil? We'll talk about air pollution. Look at those factors as well. Do we, what's going on with Clean Air Act? What's happening with human health in regards to water quality, air quality, other factors as well that fit under the abiotic components of ecosystems. We'll also spend some time talking about energy. Big issue. We have to have it. We are dependent upon energy. So what are the sources of energy? We'll explore fossil fuels versus alternative energy. You hear today in the news, oh, we have clean coal, we're using natural gas, we're using all these other sources. What about the renewables? What about solar, wind, geothermal, etc.? Let's look at energy issues. What are the pros and cons of each type of energy source? Can we find ways to use energy or produce energy that has as minimal of an environmental impact as possible? What would it cost to shift over and do more solar, more wind, etc.? Not moving away from fossil fuels 100%, but finding ways to supplement and reduce our dependency on fossil fuels. So we'll spend some time on that. Biomass, actually a really cool new thing. For those interested, U of I in Champaign's doing some really fantastic research here. Might be something of interest for those of you if you're looking to stay local with your schooling. So energy, guaranteed jobs in the sector, right there. Guaranteed opportunity for employment if you move into the energy industry. And then the last part of the semester, we'll wrap up the last unit of the semester with climate change. What is climate change? No matter what people think and say, climate change is happening. It is real. So what we're going to do is look at the lines of evidence, and we'll tackle this from a scientific perspective. Here's the evidence for climate change. What are the causes? What are the potential consequences? What's going to happen? What are the projections? What are we currently seeing happen as a consequence of climate change? It is impacting us right now. What are the health implications? What are the financial implications? What are the ecosystem implications or problems that will arise from all of these issues associated with climate change? And then, most importantly, what can we do? What are some potential solutions to climate change? Are we going to stop this train barreling down the tracks? No. But can we decrease its impact? Can we lessen the damage that this is going to cause and the issues that it is creating? That's the goal. We're not going to stop it, but can we minimize it? Can we take action and be proactive in trying to make sure we leave this planet in as good a shape as possible for the next generation and the following and the following. So if you're interested in environmental science, feel free, give me a call, bounce me an email, stop by. Let me put my email here. dave.cox@llcc.edu if it's easier to call. There's the phone number, and I am in Sangamon Hall, room 2332. So feel free, get a hold of me, let me know. More than happy to get you guys involved in environmental science, and the hope is to help lay a foundation for your junior level, senior level courses. The good news, this course transfers over to UIS if anybody's interested in moving into their environmental science and environmental studies program. They take this course over there easily. We also have an agreement with Lincoln College in Lincoln, Illinois, where this course transfers over there, smooth and easy. Other schools in the state will accept it. They generally just accept it as elective hours. So no matter where you go, the credits will transfer. So call, email, stop by. Let me know if you have any questions. More than happy to see you in environmental science in the fall.